All right, sorry YouTube. There might be a lot of noise here. We're in the cafeteria and there's like 4 or 5 classes in here, something like that. But let's see. Let's see how we do. Okay, you guys ready? All right. So I have this thing here, and it says a company designing spinning toys using the family of functions. And here's the family of functions, where C is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis, and the graph of y equals cx squared of 4 minus x squared. For some C, each spinning toy is in the shape of a solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. Okay, I can see what type of toy this is. Can you guys see what type of toy this is? It's one of those that you spin it and they like spin. Okay, I like that. That's cool. Okay, letter A. Find the area of the region in the first quadrant bounded by the x-axis and the graph y equals cx squared of 4 minus x squared for c equals 6. Okay? They're not asking anything crazy. Area under the curve. We've been doing that a long time now. So all I got to do is find, I know that the starting point is 0 here. I got to find what's the x value of that. And I know that I'm integrating this curve to find this area. Make sense? Okay. Here's the equation. That's this equation. They told me what my C value is. Are we still okay? Here we go. From your algebra, my lower limit is 0. What do you think my upper limit is? What is it? No. No. What did you say? You said 6 or what? No. No, I know my C is 6. Guys, look at this. When does this hit the x-axis? When the y value is 0. So that happens at 0 because x equals 0. What else will give me 0? Did you say 2? You gotta be, guys, you gotta be able to do that. No calculator. You gotta be able to recognize 2 squared is 4 and 4 minus 4 is 0. So, guys, make sure that we know algebra that we can do zeros. And then this is what I'm integrating. 6x square root of 4 minus x squared. And then I'll put the dx. Using all the tools at your disposal. I need to integrate this. How am I going to integrate? What do you notice? What am I going to use? USA. Good job, Morales. U equals 4 minus x squared because du is going to be negative 2x dx. Guys, we got to recognize that. If not, you're just going to be staring at a paper for 10 minutes. So here we go. I see a 6. So here's what I'm going to do with that 6. I'm going to turn it into a negative 2. And you know what? Let me put it in a different color. I'm going to turn this into a negative 2. And then what do I put on the outside? Yeah, so I haven't. I don't need to balance anything. That negative 3 times negative 2 is still my 6. Do you guys see that? So here we go. Negative 3 integral. I'm going to have new limits. Square root of u. So I'm going to write u to the 1/2 du. Put the du in the end. That's what the du is known to be the end of that integrand. Are we still okay? Okay. New limits. When x is 0, what is u? When x is 2, what is u? This is just begging to flip the limits. Just begging. 3 integral 0 to 4 u to the half. I still haven't done antiderivative. There it is. What's up? No, you could have left it like that and then just done upper minus lower. But if I flip it, I'm in the right order. My lower limit is a smaller number than my upper limit, and I have a positive number in the front. What's up, Kyle? Hit me. Uh-huh. I didn't divide anything. -3 times -2, that's your 6 there. That's what I initially had, see? If you yeah. If you want to think of it like that, that's fine. Yeah. Like I plugged in a negative no, I don't see it. Oh, 6 divided by 2 divided by 3 was -2. Negative, yeah, I divided by -3, so I had to put a -3 on the numerator. Yeah, if you think like that, that's fine. But I kind of, in my head, I just kind of see it as that's still 6, so I don't, you know what I mean? But, as long as the logic flows, you're fine. All right, you ready? All right, guys, this is true in life as well. You don't have to go back to your ex. You have limits. If you have limits, we're not going back to our ex. We have boundaries. Now, there's no limits. It was never about us. Then we go back because it was not about us. But right now, it is. There, we have limits. Done. Clock it. Okay. Here we go. Here we go. 3. Did I use it right? Because sometimes, actually, if truth be told, sometimes I do it wrong on purpose. Just okay. I'll stop. All right. Here we go. Antiderivative. Add 1 to that half. U to the 3 half. Divide by 3 half, which is the same thing as 2/3. Yeah. Dividing by 3 halves is the same thing as multiplying by 2/3. Put a line. Lower limit 0, upper limit 4. The 3's cancel out. And I guess you can factor out that 2. 2, giant parenthesis. You don't need to worry about the 0. 4 to the 3 halves minus 0 to the 3 halves. We still okay? All right. Square root of 4 is 2. 2 to the 3rd power. 8 times 2. Done. Well, easy is relative. It just depends. All right. I'm running to my second. I know. You have to be in there. Kalia Kyle did a really awesome impersonation of her running. She's going to come out in the movies. All right. Letter B. Everyone go to letter B. It is known that y equals cx squared root of 4 minus x squared. It is known that for y, okay, the derivative is that. So they give me the derivative. For a particular spinning toy, the radius of the largest cross-section, circular slice, is 1.2 inches. This is the largest area, largest radius. What is the value of C for this spinning toy? Okay, let's go back and look at this. Do you see where the biggest slice is at? Right here. You guys see that? This is a disc. Not that it matters at the moment, but the radius is the distance from the x-axis to that curve. Do you guys see that? Well, that curve is this one, the same one that we've been working on. What do you know? What do you know about maximums? Tell me something about the derivative. From positive to negative. And the derivative has to go from positive to negative, right? So that means the derivative had to have equaled 0 at that moment. So that's what I'm going to do. I'm going to come back and I'm going to say, well, that's the largest slice. That means dy dx has to equal 0. Do we see how we did that? Well, here's dy dx. The only way dy dx will equal 0, who cares what c is? We got to solve for c. The only way dy dx will equal 0 is if 4 minus 2x squared equals 0. So I'm going to go 4 minus 2x squared equals 0. And now I'm just going to do algebra. I'm going to move the 2x squared to the right. 4 equals 2x squared. Divide both sides by 2. 2 equals x squared. And then take a what? A square root. Square root of 2 equals x. I guess you can use the mirror property or symmetry property and say x equals square root of 2 or whatever. But there it is. They don't want x. They want c. Okay, I need x first. Why do I need x? Well, don't I know that the radius is 1.2? Guys, this is my radius. This in burnt orange, that's my radius. So if this is my y value, just set the function that you have equal to 1.2 at that x value. Because that x value right here, that's square root of 2. Because that's where the max happened. That's where I found my derivative to be 0. Is this making sense? So there it is. I have an equation. I have two unknowns. Well, actually, I have one unknown. And everything else, I'm just doing algebra. What's my y value? What's the distance from the x-axis to the top of that curve? 1.2. So I'm going to come here. I'm going to write 1.2 equals c. And I know what x is. Square root of 2. See, that's what that is right there. Square root of 4 minus x squared. So square root of 2 squared. There it is, guys. You're done. You're just doing algebra now. 1.2 equals c square root of 2. Square root of 2 squared is 2. Oh, look how funny these guys are. 4 minus 2. You probably don't have to show that step. You can probably just go right to this. 1.2 equals c square root of 2 times square root of 2. What's square root of 2 times square root of 2? 1.2 equals 2c. How do I get c by itself? What's the c value? Let the record show that it's not a fart. Yeah, there's just a whole bunch of noise going on right now, guys. We're in building a new building. They're building a new building. We are. I'll just stop. No, C is just a constant, but I like that you said there's units. All this is in inches. So, all right. Pretty cool, right? All right, let's go to letter C. For another spinning toy, the volume is 2 pi cubic inches. Okay. What is the value of C for this spinning toy? They're testing to see if you know how to do antiderivative and if you know that you're supposed to integrate the area cross section. All right. Look, here it is. What shape is that cross section? A disc. Yeah, the technical term is disc, but you can say circle. How do I find area of a circle? There it is. By the way, this is my radius. The radius is the distance from the x-axis to that curve. So this is my radius, guys. So I'm going to come and I'm going to say volume equals pi integral volume is 2 pi cubic inches. I'm going to set it equal to 2 pi. What? Yeah, I was going to put the 2 pi on afterwards, because that's what we're trying to solve for C, you know what I mean? Volume equals pi integral from what to what? 0 to 4, open parentheses, write it with the letter C. Cx square root of 4 minus x squared. Put a square on it, dx, pi r squared. Was it a 4 or was it a 2? It was a 2. Thank you, miss. It's this one. It's this value right here. That's a 2. Yeah, where you get the 0. So it's a 2. It's that number right here. Okay, are we still okay? All right, law of exponents. That's what they're seeing if you know algebra. So you see that square? C times C. C squared. X times X. X squared. And then the square root squared, just 4 minus x squared. So here's what I have. Pi C squared. I put the C squared out there, guys, because that's also a constant. Integral 0 to 2, x squared, parenthesis, 4 minus x squared close dx. Bam! Bam! Pi c squared integral, let me write it a little lower. Pi c squared integral 0 to 2 4x squared minus x to the 4th. And then put the dx. Are we still okay? All right, I know this all equals 2 pi. I'll put it in the end. Equals pi c squared, bracket, antiderivative of 4x squared. Not everyone at the same time. Yep. Antiderivative of x to the 4th. Yep. 0 to 2. You gotta have a little bit of arithmetic skills. Don't worry, guys. I have a filter in my laptop, and when I produce a video, you won't hear as much noise. All right. Let's do upper minus lower. We don't care about the 0 because the 0 will 0 out. In this case, not always, but in this case, but the 2. So here it is. Pi c squared, bracket, 2 to the third power is 8. 8 times 4 is 32. Man, if we can teach here, we can teach anywhere, right? All right, over 3. I don't see any issues right now. I think we're okay. Minus 2 to the 5th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32 over 5. Are we still okay? Yes. The answer to that is always yes. Thank you, miss. I'm going to get a common denominator because I have to, like to solve, right? So I'm going to multiply this by 3 over 3. Multiply this one by 5 over 5. I know. Pi c squared, bracket, let's see, 5 times 3 is 15, and then 2, 4, 6, 8, 10, so 160. I have to do it in pieces. Do you guys see how I did it? 5 times 3 is 15, so 15 in the bottom. Minus 30, 60, 90, 2, 4, 6, 96 over 15. Are we still okay? All right, here we go. Pi c squared, 160 minus 96. Let's see, 160 minus 100 is 60. Add 4, 64. All right, finally. What do I set this equal to? All right, the math is not too much extreme now. I have a pi on the left-hand side, I have a pi on the right-hand side. Bam, bam, those are outs. So at the moment, here's what I have. I have 64 over 15 c squared equals 2. I'm going to multiply by the reciprocal. Times by 15 over 64. Times by 15 over 64. C squared equals, here's how I like to do it, guys. You can say 30 over 64, but I think it's easier for me at least if I say 2 goes into 64 32 times. So I'm going to say 15 over 32. And then last move. How do I get C by itself? I know, it looks like a weird number. We checked it this morning. It was correct. How do we feel? Pi r squared. That's the area of a cross section. And we're adding an infinite amount of cross sections. And that's what creates volume. That's what creates depth. Look at you, Miss Kyle, understanding the concept at its core and not being a robot. So I need you to help your peers. Not these peers, but like, not you. You got it. You know, but like not everyone got it as you saw in the morning. All right, you guys ready for the next one? Hey, where'd you get that Dr. Pepper? You just went in, or you voted? Did you just go in? Okay. Yeah, already voting. Oh, okay. All right. Well, because I wanted Dr. Pepper. All right. This is from the 2022 AP exam. This is Calculator Active. Does everyone have a calculator? All right. So here's my calculator. Well, I don't have a calculator, but I'm getting it though. I actually have a TI Inspire also too, but I like the 84 for this. I still have your Inspire. I remember you gave a blue one. It's a CAS. It was on test mode, and you gave it to me, and you're like, "Can you get it out of test mode?" And I'm like, "Yeah, it's out of test mode. Yeah, you can't use it in SAT, but you should still have it just in case. You know, I'll bring it. All right, here we go. Let f and g be functions defined by f of x is an ln, and g of x is x to the fourth plus 2x cubed. The graph of f and g is shown in the figure in the right intersect at -2, so I'm going to put a point there, and at x equals b. So at x equals b, I'm going to put that as a point b like that. I just labeled it b. It tells me there where b is greater than 0. Yes. Find the area of the region enclosed by the graphs f and g. I love it. You have a calculator, so they don't want to see you do the antiderivative. They just want to see the setup. They're not testing. Don't worry. They will test you later on if you can take an antiderivative, like you saw over here in the non-calculator. So don't worry. Right here, they're just testing. Do you know how? Can you show me the setup and what is that area? So the first thing you should do, what I would do, I would say this expression equals this expression. So I would go ln of x plus 3 equals x to the fourth plus 2x cubed. That's what I would show first. That's how I'm finding my intersections, right? And I know one of the intersections is x equals -2, so I would say x equals -2 like that. And then the other one, I'm going to write x equals, I don't know what the other one is. I'm going to type this into y1 and this into y2, but do not write y1 and y2 on the paper, guys. What's up? Oh, right here. Yeah. So here we go. Where's my calculator? Did it go away? I pushed it. I thought I pushed it. All right, what's my y1? ln x plus 3. Thank you. What's my y2? Plus 2x cubed. Okay. On this one, I like the calculator better than Desmos on this one. Why? Because I'm gonna find the intersection and I need to store that value. And I don't. Later on, we'll see if we can store values with the Desmos, the watered down Desmos. So click on Window, and I'm gonna make my window look like this one. See, look. Let this give you the hint. So I'm gonna go a little to the left, 2.5. I'm gonna go to 1.5. I'm gonna go to like -2. I'm gonna go to 1.5. So -2.2, 1.5, -2.5, and what do we say? 1.5. Graph. Okay, it looks okay. I'm going to tell my calculator to find this value way over here on the right-hand side. Second, calculate 5, enter, enter. Guess, scroll to the one you want. We want this one. It needs to say the word what? Intersection. Go to the home screen. Hopefully you have enough short-term memory. 0.781. Go to the home screen. You push X. You push store. And instead of using A, which you could, I'm going to use B. Why am I using B? Because they used B. They told me B. Enter. There it is. So I'm going to come over here, 0.78197. I like to write as many digits as possible. 0.7819. Give me more. 7514. And because they stored it into B, see how it says B? I'm just going to go equals B. This time it's perfectly fine saying equals. You can probably even use arrows. All right, here we go. Integral. Look, they give the functions names. F and G. Do not call it y1. Do not call it y2. Do not change the name. There's no reason for it. Integral. What's my lower limit? -2. What's my upper limit? B. What curve's on top? F of x. So I'm going to write f of x minus what curve's on bottom? Done. Well, now I got to give the answer, but done. The answer can be truncated. But the B, put all the digits like that. Well, preferably. You're probably fine with 3 digits after the decimal. But, you should probably write it all out. All right, here we go. Math 9. Was it -2? -2, alpha B. And I have it in y1, the f. So alpha trace y1 minus alpha trace y2. Did you get 3.603 or 604? This one, right? 3.603. 3.603 or 604, whichever you feel compelled. This is f of x. This is g of x. Are we still okay, guys? All right. Letter B. Between -2 and B, let h of x be the vertical distance between the graphs of f and g. Okay. It can be any vertical distance. That's the biggest. Is h increasing or decreasing at x equals -0.5? Here's the reason for your answer. Okay. I love it. Vega loves it. You love it. Look at this. Because I like how you saw it by just looking at it. So h is the vertical distance between the f and the g. If you move left to right, 0.5 is like right here. What do you think is happening to that distance? Is the distance getting smaller? So then that means for sure it is going to be, but you can't just say, oh, it's decreasing because I can see it, So what do you got to do? You got to give a model. So you're going to go h of x equals upper minus lower. And then what do you think I do with that model? I take a what? Take a what? No, not antiderivative. Remember in the first semester when we were doing graphs of f prime, and f double prime? And I told you that if f prime was positive, what was happening to f? And if f prime was negative, what was happening to f? Okay, same thing with this. They want to know if h increasing or decreasing. So I'm going to take a what? Derivative. And if it's positive, h is. And if it's negative, h is. We already know just by looking at it left to right that these distances between f and g are getting closer together. So it's supposed to be. All right, so let's see. Guys, you have a calculator. You don't have to show them the derivative. You just got to show them the setup. Trust me, they're going to test you with derivatives later on anyways. All you got to do is say h prime of -0.5 and then give the answer. So here's my setup. Well, here it is. Here's the model first. And they're going to go like this. H prime -0.5 equals, and then don't even think about taking a derivative. Just do it with your calculator. Well, we're taking a derivative, but don't think about showing any expressions. Just give me a number. Go to the calculator, go math, and look for the one that says derivative. Now see how I'm warmed up from the morning, so now this time it's way better. Yeah. There it is. Guys, I guess you can probably get away with ddx of h, but don't use that. You already showed it. You said h prime. Type in x here, and then on the inside, I'm going to go alpha trace y1 minus alpha trace y2. That's f of x minus g of x. Do you guys see that? And then what's my x value? What x value do I want? -0.5. I'm just going to put -0.5. Bam. There it is. By the way, we saw the rubric this morning. You can write negative 0.5999999. Like if you always just want to write, I just want to write whatever the calculator says. It's perfectly fine if you say negative 0.6 on this one. But there it is. If you have a fancy calculator, it's not going to say 0.599. It's going to say 0.6. Love it. Love it. Cool or not cool? All right, now give me an explanation. What's happening? Because what? Yeah, because h prime is negative at that moment. So you're going to say h, and make sure you tell it at what time, guys. H is decreasing when x equals negative 0.5, since h prime of negative 0.5 is negative. There it is. Perfect. Full credit. H is decreasing when x is negative 0.5, since h prime of negative 0.5 is negative. How do we feel? Okay. Ready for letter C? The region enclosed by the graphs F and G is the base of a solid. Cross sections of the solid taken perpendicular to the x-axis are squares. Find the volume of this solid. I love it. Look at this. Here's my cross section, and let's see if I can make it three-dimensional. There's my square coming out of that board. I tried to make it as three-dimensional as I could. I got a D in art. It's the best as I can do. All those cross sections, all of them, that's just one. All those cross sections, I need to add them up. How do I find area of a square? S squared, side squared. So look, find this length, which we already know, f of x minus g of x, and we're going to, that's it, from negative 2 all the way to b. So come here and put volume equals integral negative 2 to b. There's no pi on this one. We're not rotating or anything. Open parenthesis, f of x minus g of x. Close it, put a what on it? dx. Do I have to show them how to do the antiderivative? No, it's a calculator. There it is. This is a setup. Just give me the answer. Let's go to the answer. Math. Oh, ask me. Say it again. What value? No. This was just upper minus lower. And that's not like, I mean, I guess you could write this in y3 and then put y3 squared in the calculator. But no, like, don't. Like, that's just a model for what h of x was, you know? All right, here we go. Math 9, negative 2 to b. And let's see, open parenthesis, alpha trace y1 minus alpha trace y2. Close parenthesis, put a square on it, and x. There it is. Did you guys get that? 5.3401. The more digits, the better. 5.3401. We're still okay? All right. Letter D. A vertical line on the xy plane travels. I actually had to read this one twice this morning. A vertical line on the xy plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross-section above the vertical line with respect to time when the vertical line is at position negative 0.5. I had to read it twice. Before we even start, 7 units per second, what is that? The vertical line is moving left to right at 7 units per second. So what is that 7 units per second? Give me the symbols. No, it's just 7 units per second. But it's moving left to right at 7 units per second. So that is horizontal motion. So give me what is it, a dy dt? Is it a dx dt? Is it a dv dt? It's a dx dt. 7. Are we still okay? All right. What do they want? Okay. What do they want? Like the notebook. When the notebook at the very end, what do you want? What does it want? The rate of change of the area. The area of what? No. Hey, be careful. Hold your horses. Let's read it again. Look. Find the rate of change of the area of the what? Do I have, how do I find, so this is my cross section. What is the model for that cross section? This guy right here. Wasn't that my A of X? That was your A of X, right? Do you guys know what I'm trying to get to? Yes, that's exact. My A of X was F of X minus G of X. That was my area. And they want to know how fast, look what this says, find the rate of change of the area of the cross section. So I need to take a derivative of A of X. Yes. With respect to what? No, not X. T. Find the rate of change of area of the cross section above the vertical line with respect to time. So you guys ready? So here we go. dA dt equals, bring the 2 to the front, f of x minus g of x, close it, power 2. Am I done? Am I done? Chain rule. Oh, and it's not power 2, by the way. Yeah. Times, yeah, I just messed up there. All right. 2 f of x minus g of x to the power 1 times the derivative of the inside, f prime of x. But am I taking this derivative with respect to x or with respect to t? dx dt. Put it right next to it. It's not an x. I'm taking it with respect to t. Minus, what's the derivative of g? G prime of x. And then what do I put next to it? Now, I did see the rubric. I am biased because I saw the rubric already. The rubric, and I did like what they did, they factored out the dx dt, but I didn't do that the first time, so I'm not going to do it. I'm going to do it the same way that I did it last time. You know what I mean? There it is. This is the setup. I'm just gonna tell it. I'm going to go dA dt when x is negative 0.5 equals, and I'm just going to give the answer. So I take my calculator and I go like this. I go, let me clear everything. Ready? 2 times math, which one? Number 8. Put an X on it like that. Have I confused anyone? Open parenthesis, write alpha trace y1 minus, I already messed up a little bit. Sorry, guys. Let me do it again. 2, and in the beginning, look, this is not a derivative right here. 2 f of x minus g of x. I want it to look like that. I could have continued, but I want it to look like that. 2, open parenthesis, alpha trace y1, plug in a negative 0.5 in there. Negative 0.5 minus alpha trace y2, open parenthesis, negative 0.5. Close. I'll wait for everyone to get here. Is everyone right here right now? No? No. It's okay. It's okay. I wanted to go back to that. I hate sitting down for so long. Why is this so low? Ah! I'm doing this. 2 f of negative 0.5 minus g of negative 0.5. And now I gotta take time. Now I'm gonna take derivative of this times 7 minus derivative of that times 7. So open a parenthesis. No. So here we go. I hate sitting down, man. Okay, sorry. So here we go. Open a parenthesis. Math number 8 x, and then put alpha trace y1, and then at what x value? So there it is. And then I come out like that. You see how I'm already out? And I go times 7. That's what I did earlier, like that. Times 7. See? Minus, no, it's a minus. Remember, it was f prime minus, or f prime dx dt times 7. Okay. We're still okay? Minus math 8x alpha trace y2 at negative 0.5, scroll to the right, and then I come out of there and I go times what? 7. Close the whole shebang. Enter. Did you guys get that answer? Yeah, you got to be very careful with your parentheses, guys. All right, you ate the cookie. Better just give it to me. 9.2718. With a negative. You want me to scroll right? I'll push enter and I'll scroll right. There it is. You guys see what's going on? I know. There it is. Are you ready for one more? It's taking longer because of all that. Snacks? I don't have any. Glue sticks, yes. Yeah. Can I eat? You can go. Okay. Do I have access to a calculator for this one? Okay, let's close the calculators. See, they're going to test you whether if you on this one in particular, they're really testing to see if you know how to do antiderivatives. Letter A, huh? This one we haven't done. We've done something similar, but not this one. Yeah. Does that one look very familiar? Yeah. I don't think. Maybe you did A. Yeah. I think maybe. I think we've done y equals x and y equals x squared. That's the theme. I'm just going to put grr. Okay. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared, as shown in the figure to the right. Find the area of R. Guys, I hope you can tell which one's linear. This one's y equals 2x, and which one is not linear. Notice that they didn't give the functions names, f or g. They want to see all the steps. Whenever they don't give it names, they want to see it. So here we go. They tell you the intersection. They're being nice. They didn't have to. How do I find the area of this? What do I write? Tell me what to write. Integral from what to what? 0 to 2. Which one's on top? 2x. Which one's on bottom? And then don't forget the... If you guys want to put parentheses, you can. You don't have to. They want to see you do an antiderivative. They want to see it. So definitely you have to show it. What's antiderivative of 2x? X squared. What's antiderivative of x squared? There you go. I'll put a line. Lower limit 0, upper limit 2. If you want to put a bracket, that's fine. No big deal. Are we still okay? All right. Upper minus lower. The 0 is not going to matter in this case. But be careful, because in the next one, I bet you they caught a lot of people. All right. Plug in a 2. 2 squared minus 2 to the third power is... And I guess I should have written 4 here. If you are scared, which I'll tell you by the time we take mock exam 3, I'll look at the patterns for you. And if you are constantly making mistakes with arithmetic, I will tell you to stop. But right now, I want you to be courageous. You can leave it like that. That will be full credit. But I want you to be courageous. I'm going to multiply this by 3 over 3. So here we go. 3 times 4. And 12 minus 8. So this is going to be 4/3. Oh, it was? Okay. But not letter B, though. Look, letter B, look, they're testing to see if you're a robot or not. Let's do letter B. The region R is the base of a solid. So I'm not rotating anything. It's just, that's the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals that. Find the volume. So today when we did this in first period, they're like, Chav, I don't know what to do. I don't know where to integrate. What's my model? Look, they are giving it to you guys. They're telling you this is my area cross-section. So you have to do no work. You don't have to do any real thinking. You're like, oh, volume equals? No, we're not squaring anything. This is my cross-section. Yes. Integral from what to what? 0 to 2 of this. I have a theory that I think in this test, this particular year, they were testing to see if you guys really knew how to take antiderivatives. So that's why, you know what I mean? What? Yeah, go ahead. That's my cross section. You don't have to worry about what. That's remember, for volume, you got to integrate your cross section. That's my cross section. They give it to you. Are we okay, Kyle? It's not a square. It's not a radius. I'm not rotating anything. Plus, they told you, look, you're always to get the volume. It's always going to be Miss Kyle, a cross section, an A of x, area. That is A of x. They're telling you. You know what I mean? Okay. All right. Here we go. What's antiderivative of sine? Negative. Notice I put some room. Cosine of pi over 2x. Now, I have a linear argument on the inside. You could have done u sub. You could have. But just take the what? The reciprocal. Do you guys see that? You could have done u sub. U equals pi over 2x. Du equals pi over 2 dx. Oh, there's no pi over 2 in there. Let me put a pi over 2. You put a pi over 2. What do you put on the outside? 2 over pi. You could have done u sub. But if it's a trig and it's linear, I want you to be able to just do it. Come on, Vega. Does that make sense? Okay, I put a line. I only have one term from 0 to 2, and I bet you there was so many kids that probably lost a point because they didn't bother doing the 0. The 0 matters on this one. All right. Upper minus lower. I'll factor out the negative 2 over pi. Whatever you have in the front, I factor it out. Bracket. If I plug in a 2 pi over 2, the 2's cancel out. You get cosine of pi minus cosine of 0. Are we still okay? Negative 2 over pi times cosine of pi is, do you remember? Negative 1, and cosine of 0 is another 1. What's negative 1 minus 1? Negative 2. What's negative times a negative? So I'm going to have 4 over pi. Does everyone see how I got 4 over pi? That was negative 2. Negative 2 times negative 2. Father 4. Bless you. Bless you squared. Bless you cubed. Bless you fourth. Maybe you got to run. Are we okay, guys? Last one. Letter C. Another solid has the same base R. For this solid, the cross sections perpendicular to the y-axis. Underline that. Are squares. Right? But do not evaluate. Probably because it would take forever, maybe. I don't know. Bless you squared. Bless you cubed. It's all the dust from that. An integral expression for the volume of the solid. Okay, guys. My cross sections are perpendicular to the y-axis. It's this. This is my cross section. It's coming out like this out of the board. That's to the 5th power. What is this cross section? Is that a dx or is that a dy? It's a dy. Do you guys see that? I need these answers in terms of y. So x equals something with the y's in it. So this, what was that? Y equals 2x. And this was y equals x squared. So here it is. Bless you. No, you're fine, miss. You're fine. X equals y over 2. Is everyone okay with that? This one here. X equals square root, the square root of y. Is everyone okay with that? Here we go. What's my cross-section geometry, Miss Kyle? What shape is it? So how do I find area of a square? S side squared, yeah. Volume equals, there's no pi's on this one. Integral, what's my lower limit? 0. What's my upper limit? What is it? Yes, good job. 4, the y value. All right, open parenthesis. What is considered the top, quote unquote? Yes, square root of y. Minus, what's the bottom one? Y over 2. Close it, put a what? There it is, because this is gonna give me, this is my model for how the length of one of these sides, and you're gonna square it, and then don't forget the what? The dy. This is called the differential. If your professor is like, oh, what is this? Oh, that's the differential. Okay, there it is. Do I have to solve it? We're good. This is the answer. How do you feel? All right, do you have a Delta Math, a whole bunch of practice? You can relax today. I didn't make the Delta Math due till sometime later. No quiz tomorrow. Did going over this help? Are we getting stronger, better, faster? Stronger, better, faster, stronger. Okay, sorry, Daft Punk. Do you guys know who Daft Punk is?